Bismillah ar-Rahman ar-Rahim. My dear students, I am Mr. Shinwar and my dear friend Mr. Omer. We intend to make a series of video records about chemistry grade 12. In this series, we are going to explain chapters, solve chapters, reviews, and solve some wizard questions. First, I will start with first chapter. In fact, it's not included in Wizari exam. However, there are some terms you should know before we start with next chapters. So today, I am not going to solve questions in the first chapter that exists in the first chapter because, as I said, it's not included in Wizari. Only the thing that I need you to know is that you should know some terms before we start with the next chapters, second and third chapters. This chapter is about the solution. The first chapters from your chemistry book is about the solutions. Actually, there are some terms, as I said, you should know. They included soluble, solution, solvent, solute, suspension, colloid, electrolyte, non-electrolyte, and you should know as well as the concentrations, including molarity and molarity. Okay, let's start with the mixtures. Mixtures generally are divided into homogeneous mixture and heterogeneous mixture. Homogeneous mixture is like a solution. When you put NaCl in a beaker or volumetric flask like this one, then you add some water over it, you will find it get dissolved. You will find the small crystals, white crystals of sodium chloride disappear. This tells us that the sodium chloride is dissolved in water and you will get a homogeneous solution. You will not find any particle in that solution. However, in case of milk, you will find many suspension particles on it. So the milk therefore is heterogeneous mixture, and the salt dissolved in water is homogeneous mixture. So we have two types of mixtures, homogeneous and heterogeneous. Homogeneous is clear, the solution is clear, while in case of heterogeneous mixture, it has suspended and colloid particles on it. Example of heterogeneous mixture is orange juice, blood, milk, etc. And examples of homogeneous mixture includes sodium chloride dissolved in water, sugar dissolved in water, and etc. Okay, here we have a solution. Solution generally consists of solvent and solute. The solvent, the dissolving medium is in a solution is called a solvent. For example, when we have water and salt, water is a solvent, salt is a solute. So we can define the solute as the substance get dissolved in a solution to make a solution. Get dissolved in a solvent to make a solution. Okay, we have type of solutions. Of course, when gas, okay, like oxygen in nitrogen. When another type of solution is the gas in liquid, like carbon dioxide in water. Liquid in liquid, when alcohol, ethanol is dissolved in water. Liquid in solid, mercury in silver. Solid in liquid, like sugar in water, like salt in water. And solid in solid, like copper in nickel, or like silver in gold, as in the following ring example. In case of heterogeneous, as I have said, the solution is a homogeneous mixture. The two examples of heterogeneous mixtures are suspension and colloid. Yes. In suspension, the particle size is large. The particle size is over 1000 nanometer. While in case of colloid, the particle size is less than 1000 nanometers. We have a table here in which it differentiates between solution, suspension, and colloid. Of course, you have some classes of colloids. You can just read this table for knowledge. As I said, this chapter is not included in Wizari exam. Here we have Tyndall effect. Tyndall effect is a phenomena in which you can differentiate between the colloid and the solution. The colloid scatter the incident light, as in this picture. The colloid scatter the incident light. So you will find the colloid solution like this glass. While in case of solution, the incident light passes through the solution, because as we said, the solution is clear. So you will not get the light scattered in solution. So you can differentiate, in this case, you can differentiate between colloid and solution. This table explains some differentiations between solutions, colloid, and suspensions. As we said, solutions are homogeneous, colloids are heterogeneous, and suspensions are heterogeneous as well. The particle size of colloid is less than 1000, and the particle size of suspensions is over 1000 nanometers. Colloids you cannot separate them easily, while the suspensions we can separate them easily by filtration, or just they will settle down after time. In case of solutions, solution is homogeneous, and the particle size is very small, less than 1 nanometer. That includes atoms, ions, or molecules. We cannot separate them, and they do not scatter the light as well. Here we have another term which is called the electrolyte. Electrolyte, when we dissolve salt in water, the salt is separated into a positively charged sodium ion and negatively charged chloride ion. These two ions conduct electricity, so it called electrolyte. So they called electrolyte. However, in case of sugar, for example, if you have sugar dissolved in water, sugar will not turn into ions. Sugar will stay as a molecular form in the water. So sugar solution will not conduct the electricity. Such solutions are called non-electrolyte. This picture explains what I have just said. Here we have salt NaCl get dissolved in water. The NaCl is turned into chloride anion and sodium cation. The anion of chloride and cation of sodium conduct electricity. So this solution is called electrolyte. However, in case of sugar get dissolved in water, the sugar stay as a molecular form. The sugar stay in water as it is a molecular form. So it will not conduct electricity. So the solution of sugar and water is called non-electrolyte. The sugar is called non-electrolyte solute, and the solution of sugar will not conduct the electricity, as in this picture. Here we have review questions. Actually, I will not spend time here because you will not benefit from these questions. They are not included in Wizari. So we will go to second section. In the second section, the solution processes, we have some terms here as well. Solution equilibrium, saturated solution, unsaturated solution, and supersaturated solution. We will have another term which is called solubility, hydration, immiscible, miscible, Henry's law, effervescence, solvated, enthalpy of solution. Some of the following terms are very important for you for the next chapters, and other terms are not so important. So just we will go through it. Actually, when you put a piece of sugar in a hot water or in a water, there are several factors that affect its solubility. Okay? The first factor is the increasing the surface area of the solute. If you put the powder sugar into the water, it will get dissolved quicker than if you put a cube of sugar. So the surface area play a role in solubility, in dissolving process. Here is the example. Small surface area exposed to solvent sluride. Okay, we have a piece of copper sulfate here. The surface area is small, so the dissolving process will be slower. But here, large surface area, we have very large surface area. We have powder here, so the exposed to solvent is faster. Have a larger surface area, so the dissolving process is faster, it's quicker. Agitating a solution, of course, when you agitate the tea, including the sugar will get dissolved faster. Heating a solvent, when we heat the solvent, we increase the dissolving process. Here we have another term which is called solubility. Solubility, each chemicals, each solute has its solubility in a specific solvent. For example, 200 grams of sugar is get dissolved in water. Let me start from. Yes. Before I define solubility, let's start with the solution equilibrium. Actually, the solution equilibrium is defined as the physical state in which the opposing process of the dissolution and crystallization of a solute occur at equal rate. We can say that the solution will be in equilibrium when the rate of the dissolving is equal to the rate of the crystallization, of the precipitation. We say in this case, we say the solution is at equilibrium. Here we have 3 points. We have unsaturated solution. Unsaturated solution means when you put more solute, it would get dissolved in the solvent. This solution is called unsaturated solution. However, saturated solution, when you put extra quantity of solute, it will not get dissolved in the solvent. It will precipitate. So in this case, the solution is called saturated. In case of supersaturated solution, when the solution contains more dissolved solute than a saturated solution, under the same condition, we mean condition here under the same temperature and pressure. In this case, if you have more quantity of solute dissolved in this solvent, more than the saturated solution, this solution is called supersaturated solution. How we can get the supersaturated solution actually? We can get the supersaturated solution when we heat the solution and then we cool down again. So it will contain more solute get dissolved in the solution at a specific temperature and pressure. Okay. Here we have solubility. For example, the solubility of sugar, when we mention the solubility, we should mention the quantity of solute dissolved on the quantity of solvent at a specific temperature. Okay, let's bring some examples. Sugar, for example. Sugar, 204 grams of sugar, 204 grams of sugar can be added to 100 grams of water at 20 Celsius. What this tells us? This statement tells us that at 20 Celsius we can dissolve 204 grams of sugar in 100 grams of water. In this case, we will get a saturated solution. If 100 grams of water contains less than 204 grams of sugar, this solution is called unsaturated solution. If the solution contains more than 204 grams of sugar in 100 grams of water at 20 Celsius, this solution is called supersaturated solution. If the solution contains exactly 204 grams of sugar in 100 grams of water at 20 Celsius, this solution is called a saturated solution. Okay, and usually the solubility is denoted by gram of solute per gram of water at a specific temperature. Here we have an important term here, like dissolves like. Like dissolves like means the polar molecule is dissolved in polar solvent, and the nonpolar molecules are dissolved in nonpolar solvents. For example, if you mix water with oil, they will separate into two phases, because the water is polar molecule, but the gasoline or the oil is not polar molecule, so they will not mix up. But if you if you put the NaCl, sodium chloride, which is table salt, in a water, this table salt will get dissolved. Why? Because the NaCl is a polar molecule and the water is a polar molecule as well, so they will get dissolved. This is what the term Lye dissolved likes is explained. Here we have the solubility of solutes as a function of temperature. Actually, not all solutes, the solubility of solutes are not increased when we increase the temperature. We have some in some specific salts, in some specific situations, when we increase the temperature, the solubility decreases. For example, calcium hydroxide and cesium sulfate. As you can see from the table, at 0 Celsius, the solubility of calcium hydroxide is 0.189 gram in 100 ml of water. This tells us that we will get saturated solution at 0 Celsius when we put 0.189 gram of calcium hydroxide in 100 gram of water. Okay, if we increase the temperature, as you can see, the quantity of calcium hydroxide is less. We can dissolve less quantity of calcium hydroxide in 100 gram of water, and so on until we reach the 100 Celsius. We will get only 0.07 gram of calcium hydroxide dissolved in 100 gram of water. The same thing is true in case of cesium solvent. However, most salts, its solubility increases as we increase the temperature. And this situation, the case is totally different in case of gases. Of course, when we increase the temperature, the solubility of gases get decreased, as you can see here in this table. Here we have CO2 gas. At 0 Celsius, we can dissolve 0.335 gram of CO2 in 100 ml of water, but at 60 Celsius, we will have 0.058 gram only of CO2 is get dissolved in water. So the solubility of gases is decreased as we increase the temperature, and the solubility of most salts is get increased when we increase the temperature, except in case of calcium hydroxide and cesium sulfate. I hope you have understood. Okay, hydration. When we have a water as a solvent, we call this process when you have a salt and the solvent is water. When you have a salt and the solvent is water, we call this process as hydration. Nonpolar solvent. You should know some of nonpolar solvents. That includes carbon tetrachloride, toluene, benzene. Most of oils are nonpolar solvents, and ethanol actually act as polar solvent and nonpolar solvent as well, because ethanol has a polar portion which is OH and nonpolar portion which is CH3CH2. This is not important for you. We will talk about it in chapter 12, inshallah. Okay, here we have another terminology in which they are immiscible and miscible. Miscible means that they will get dissolved. Immiscible means that they will not get dissolved. They will not be soluble. Okay, so what is the difference between soluble, non-soluble, miscible, immiscible? Soluble, non-soluble, this is for a solid solute in a solvent. Miscible, immiscible, this is for liquid solute in a liquid solvent. Okay, when you have, for example, ethanol is alcohol, ethanol is alcohol, ethanol is liquid. If you put liquid ethanol in water, which is liquid as well, we will say they are miscible. When they mix up, we will say they are miscible, okay? However, toluene, as in this picture, toluene is liquid. Toluene is liquid, and water is liquid as well. The upper part is toluene, and the down part is water. Toluene is liquid, and water is liquid, and they will not mix up. Why? Because toluene is nonpolar, and water is polar, so they will not mix up. They will not get dissolved in each other. In this case, we will say immiscible. Why? Because both of them, both the solute and the solvent are liquids. However, if you have a solid solute and a liquid solvent, in this case, we will say soluble or insoluble. Effect of pressure or solubility. Of course, when we increase the pressure, we will get more gas dissolved. And this is what is called the Henry's law. Okay? Effervescence is the favaran in Kurdish language. This is effervescence. This is effervescence. This usually happens in case of gases. Yes. Not so important. Again, as the temperature is increased, the volume of gases, the volume, the quantity of soluble gas decrease. And this chart explains the effect of temperature on the solubility. As you can see from here, most of solid solutes, most of the solid solutes are their solubility is increased as the temperature is increased, except in the case of calcium hydroxide, cesium sulfide, as I have just mentioned, and lithium sulfate as well. The energy component of solution formation, this is not important, just I will give you some enthalpy. So, but just I want you to understand what is the energy component with the solution. When you put the solute in the solvent, some process happens, as in this diagram. If the energy gained by step 1 and step 2 is greater than the energy given in the step 3, this solution will be endothermic. In step 1 and step 2, step 1, solute particle becoming separated from solid. This step absorb energy, take energy from the surrounding. Step 2, solvent particle being moved apart to allow solute particle to enter liquid. This is also absorbing energy, gaining energy from the surrounding. So, if the sum of the step 1 and step 2 energy is greater than the step 3, in which the solvent particle is being attracted to and solvating solute particle, the solution will be endothermic. If the sum of step 1 and step 2 is less than the step 3, then the solution will be exothermic. Okay? In step 3, giving energy, gives energy, release energy, while step 1 and step 2 gain energy. So, if the sum of the step 1 and step 2 is greater than step 3, the solution will be endothermic because it will gain, it will absorb energy from the surrounding. However, in case of step 3 is higher than step 2 and step 1, we will get exothermic solution. What is exothermic solution? Exothermic solution means that if you put the beaker in your hand, you will feel something hit your hand. If the solution is endothermic, you will feel your hand is get cold, because endothermic solution takes heat from the surrounding, so you will feel some coldness. In case of exothermic solution, it gives heat to the surrounding, so you will feel some heat in your hand. Here you have some examples of exothermic and endothermic solutions. Actually, dissolving AgNO3 is endothermic, because positive signs denote the endothermic process. However, in case of KOH, NaOH, they are all exothermic. When we put NaOH in or KOH in a beaker, we will feel something hotness, because they are exothermic. Okay, my dear students, until now is enough. For the next video, I will start with the concentrations of solution, which is a very important topic. We will need molality and molarity in the coming chapters. So see you later, inshallah. If you have any question, do not hesitate. Try to find me in Viber or WhatsApp. We will have our numbers written down video. Okay, see you later, inshallah.